Hello there, I'm Mr. Math Guy, and today we're going to take a look at a 10-minute video on differentiation rules. Specifically, we're going to take a look at the constant rule, the power rule, the sum rule, the difference rule, and the constant multiple rule. So these are 5 differentiation rules that we're going to be discussing in this video. So for this first rule, the constant rule, say we have a function f of x is equal to c, where c is just a constant. If we're trying to find the derivative of a constant, then the derivative of any constant is going to be equal to 0. This is the easiest of the rules. It's the most basic. Because if you think about it for a second, if you have f of x is equal to, let's say, 1, alright, and we take a look at the graph of this. Well, f of x equals 1 is just a horizontal line at 1. And so if we take a look at the slope of the tangent line at any particular point on that graph, the slope is also going to be a horizontal line, and the slopes of horizontal lines are m equals 0. So the slope of any constant is 0. So if we take a look at an example, and we have f of x is equal to 3. Just some number 3, a constant. Then the derivative of f of x is equal to 0. The next rule that we want to take a look at is the power rule. So if we have a function f of x is equal to x to the n power. Now I will say here that n is a positive integer, so n is greater than 0, and is an integer. We'll take a look at examples later on in other videos if n is a negative number or not an integer. But in this particular case, then the derivative of f of x is equal to, you take the exponent, which is n, and you place it in front and use it kind of like a constant or a multiple or multiplier of x, and then you decrease the exponent by 1. Let's take a look at a couple examples. First one I have here is f of x is equal to x cubed. So according to the power rule, the derivative of f of x is going to be equal to take the exponent and place it in front of the x, so 3x, and decrease that power by 1. So 3 minus 2 is, or 3 minus 1 is 2, so it's 3x squared. On our other example, we would say the derivative of f of x is equal to take the exponent, move it in front, and decrease this one by 1 power, so 7x to the 6th. So here are a couple examples of the power rule. The next rule that we want to take a look at is the sum rule. So we have f of x is equal to g of x plus h of x. And just to show you some different notation, I could also write this, instead of saying derivative of f of x or f prime of x, you can write it like this, d over d of x of g of x plus h of x. What you simply do when you're using the sum rule is you just split them apart. You'd say, well, it's the derivative of g of x, and then you just say plus derivative, or d over dx, of h of x. So it's pretty basic. It's pretty simple. You just split the two functions up and add them together. Here's an example. F of x is equal to x cubed plus x squared. What we can do then is we can say, well, the derivative of f of x is going to be, and you can just rewrite this as d over d of x, of x cubed plus x squared. Now, what we can simply do is we can just find the derivative of these individually, of x cubed plus d over dx of x squared. Now, going back to our power rule, 2 here, the power rule is going to say, well, the derivative of x cubed is 3x, decrease that by 1 power, 2, plus, this power rule says of x squared, it's the 2 in front, x, and decrease it by 1, so x to the first. We can just leave it as 3x squared plus 2x. So here's an example of the sum rule. The next rule is the difference rule. Now the difference rule is almost identical to the sum rule. The only difference being that instead of putting an addition sign, you're going to put a subtraction sign. So if I want to find the derivative of f of x, or can rewrite it as d over d of x, of g of x minus h of x, then you just split it up and find the derivative of the first function, g of x, and subtract from that derivative of the second function, which is h of x. So almost identical to the sum rule, you just put a subtraction sign instead of an addition sign. So let's take a look at an example. We have f of x is equal to x to the 5th power minus x. So the derivative of f of x, or d over d of x, d over dx, of x to the 5th minus x, is going to be d over dx of x to the 5th minus d over dx of x. Now, using your power rule, you have this first one, derivative of x to the 5th power is 5x to the 4th minus, and derivative of x, well, it's x to the 1st power, so put a 1 in front of it, 1, x to the 0. But since x to the 0 is 1, 1 times 1 is 1, so the derivative of this is just 5x to the 4th minus 1. This last rule is called the constant multiple rule. It's kind of similar to the power rule. When you got a number in front of a function, so like k times g of x, what you simply do is just, when you find the derivative of this, you just simply write the k in front and multiply it by whatever the derivative of g of x is. So it's just kind of like you pull the k in front and then go ahead and find the derivative of the given function or the known function. So a little example over on the side, if f of x is equal to 3x to the 4th, then what you would simply do is the derivative of this is, say, it's going to be 3 times whatever your derivative is of x to the 4th. And that's just simply going back to the power rule. So you would have derivative of f of x is going to be equal to 3 times, and using your power rule, that is 4x to the 3rd power. Now you can multiply there, so this derivative f of x is going to be equal to 12x to the 3rd power. So if you have that constant or that coefficient in front of a variable that's squared, just pull it out to the front and then find the derivative using the power rule and then multiply that coefficient or that constant by what you got when you did the power rule. All right, let's take a look at a problem that may contain a combination of a few of these rules. So if I have f of x is equal to x to the 4th plus x cubed minus 3x squared plus 8, then what I'm going to do is I'm going to say, well, the derivative of the slope of the tangent line at anywhere on this particular function, is going to be on this first one. Okay, you got the sum rule, so you got d over dx of x to the 4th, all right, plus d over dx of x cubed, and then you got the difference rule minus d over dx of 3x squared, and then you have plus d over dx of 8. So taking a look at these, the first power rule, it's 4x cubed, then you have plus 3x squared, and then you 3 times the 2x, which is 6x, and the derivative of a constant is 0, so you don't even have to put it in there. Thank you for watching. God bless.